All right, second day of U-Sub notes, and basically all I'm going to do is just go over a couple of examples and then give you some practice to work on for the next few days. So let's just go ahead and jump right into some of these examples. So first one up here, again, we can see our composition of function. We have a square root would be our outside function. Inside function is 2x minus 1. So what we want to check out first is, okay, if I set u equal to 2x minus 1 and take the derivative, do I end up with something that will help me be able to integrate this? And you can see here that we do. We will need to move the 2 over, so we're going to make this 1/2 du equals dx, but it's still something we can do. So let's go ahead and substitute some things back in here. So what I'm going to end up with is the integral of square root, and actually, you know what, I'm going to just rewrite this as u to the 1/2. We'll save ourselves a little bit of work there. So u to the 1/2. And now we're going to replace dx with what we know, and we know that dx is equal to 1/2 du, so times 1/2 du. Alright, so let's try and skip some steps here. This 1/2 will be factored out front, so I'm going to write 1/2, but I'm not going to rewrite all of this just to do the integral, so we're just going to do the integral now. So times the integral of u to the 1/2, we will add 1, so 1/2 plus 1 will be 3/2, and then divide by that number, so we're going to divide by 3/2. Since this is an indefinite, there's no numbers on our integral, we do need our plus c here. So now, what do we end up with here when we take this and simplify? So we're basically multiplying this by 2/3. Okay, multiply by 2/3, and what we end up with is u to the 3/2 over 3. Okay, u to the 3/2 over 3. Now, plus c. Last thing we got to do is get rid of that u and replace it with 2x minus 1 raised to the 3/2. You could leave it like that, or you can write the square root of 2x minus 1 cubed. Doesn't really matter. You're going to be looking for your multiple choice answers to see which one is correct. So there you go. Next one. This one gets a little bit more complicated because there's actually 3 functions here. Okay, we have the outside here would be, something squared, and then the inside would be sine 3x, and then we have cosine 3x. So this may be one that might, if you see a problem like this, it might take you a few steps to realize what u is supposed to be equal to. But again, keep in mind that we're looking for a function whose derivative is also there. Okay, so a function whose derivative is also there, and that function needs to be inside of another function. So if you think about it for a second, u will be equal to sine 3x. Okay, now when we do the derivative, we get du is equal to cosine 3x times, don't forget your chain rule, derivative of the inside will be 3 dx. And looking at our problem, we have a cosine 3x and we have a dx, so we need to move this 3 over. One thing I would suggest you do, just for the sake of time, I wouldn't rewrite this whole step. What I would do is just erase this and move it over here as a 1/3, just to kind of save us a little bit of time in writing, because remember, when we're doing our AP test at the end of the year, we're going to be in crunch mode, and we got to make sure that we're like really trying to use our time wisely here. So recopying that is not a good use of our time. So erase this or scribble it out or whatever, just to save you a little step of having to rewrite that. So they are equal. We just kind of saved ourselves a little bit of work. So now what does this new integral look like? Well, we have the integral, u was sine 3x, so this is u squared times, I forgot my 1/3, I almost wrote du, 1/3, because cosine 3x dx is equal to 1/3 du. All right, so now again, just like in the last one, we're going to take that 1/3 out front. Take the integral of u squared, so that means add 1 and divide by that number. So we're going to divide by 3. There are no numbers on our integral, so we do need our plus c for the constant. And what I'm going to do here in one step is, first of all, I'm going to make my denominator a 9. 1/3 times 1/3, it would be 1/9, so my denominator is 9. And I'm going to take that u and I'm going to plug this sine 3x in for u. So you can write this as sine to the 3rd power of 3x. Personally, that kind of looks a little messy to me, and my handwriting's not the greatest. I don't like the way that looks. So what I'm going to do, I'm going to opt to write this as sine 3x, that quantity cubed. I think that looks a little better. Maybe your handwriting's nicer and you can make it look a little more presentable, but I just think because this has a 3x on the inside and the exponent was a 3, I think it just kind of makes it look a little sloppy to write it the other way like this. You know, putting the 3 up here like this 2 is. So that's just my preference. And they mean the same thing, so writing it like that is perfectly acceptable. Okay, last one. I wanted to throw one in here where we had a definite integral. So this going from 0 to 1. So we're going to, first of all, we're going to start this off by saying u is equal to x squared plus 1. Because I know when I take the derivative of this, I'm going to end up with 2x dx. And again, just like in that last problem, I'm not going to rewrite this whole thing. I'm just going to move this 2. Just when you move it over, don't do this, because I see that happen a lot. People try to skip steps and end up making some mistakes. But remember, we had to divide that over, so that's going to be a 1/2. So I have x dx, just like I have x dx right here, that will get replaced with the 1/2 du. And I also have my x squared plus 1, x squared plus 1 that will be replaced with u. So now you have two options. I'm going to show you two different ways of doing this. One is just to rewrite it like this: 0 to 1 of u cubed times 1/2 du. Okay, and we go through and solve this, or integrate it first of all. So 1/2 u cubed would be u to the 4th over 4. We don't need a plus c now because we have our interval from 0 to 1. So we're going to integrate this from 0 to 1. But before that, we do need to rewrite this. So let me, first of all, we'll say 2 times 4 is 8. There's my denominator. Numerator, I end up with x squared plus 1. That quantity is to the 4th power. We're going to evaluate this from 0 to 1. So plug in 1, what do we get? Well, 1 plus 1 is 2, 2 to the 4th. 2 to the 4th is 16, divided by 8. Minus, plug in 0. 0 plus 1 is 1. 1 to the 4th is 1, divided by 8 is 1/8. So I end up with a final answer of 15 over 8, as long as I did those steps correctly. So that's one way of doing this. Now let me show you another way, which is another method that we use to redefine our limits and redefine the interval. Instead of saying 0 to 1, we can actually do this another way and end up with the same answer. So I'm going to show you that here now. The first part is the same. This right here does not change. That's exactly the same. So what I'm going to do is I'm going to pick up with this step here. So this is method number 2, okay, of doing this. So on my integral, I still have the u cubed times 1/2 du, okay? But now, instead of going through this process right here of plugging u back in, we can redefine our interval, the limit, lower and upper limits, by taking them and plugging them into this and just redefine it. So what I mean is if I plug 0 in here, 0 squared plus 1 is 1. So my bottom one could be a 1, and then the top one used to be a 1. So if I plug that in there, 1 squared is 1, plus 1 gives me 2. So I can integrate this now and say, we're still going to end up with the same thing, 1/2 times u to the 4th over 4, evaluated now from 1 to 2, which is u to the 4th over 8, evaluated from 1 to 2. And basically what this means is I can now take these new intervals and plug them in, and what you'll see is you end up with 2 to the 4th, which is 16 over 8, minus plug 1 in, 1 to the 4th over 8 is 1/8, and we get the same thing. Okay, so that's 15 over 8. So there's another reason, another way of redefining our interval, our lower and upper limits on the integral, to help us solve problems. And again, it's another way that you'll see answers written differently in your multiple choice section of the AP test. So again, it's just something else I wanted to point out to you. I will be sending out some practice problems on that throughout the week. Yeah, so first of all, here's a couple problems from your book. So give those a try, and if you have any questions, just let me know. But I'll basically be going over some problems throughout the week, just on U-substitution, just different methods and different forms that you'll see them in. Yeah, just sending you some more practice problems and stuff. So if you have any questions, just let me know.